Woohoo! Go Bearcats!
Good evening, Bearcats. Alright, we are now going to start day 1 of 2.5, zeros of polynomial functions. The zeros, as you know, of a polynomial function are the same as the x-intercepts. So that's really important. They are the ordered pairs along the x-axis, which will help us graph our higher degree polynomials. A couple of theorems that I want to talk about. First is the fundamental theorem of algebra, and that is when f of x or y is a function is a polynomial of degree n. That means it's like x to the nth degree, which means and x is greater than 0. So it could be x to the first technically, or x to the 10th. Then f has the function has 1 0 in its complex number system. So it has at least 1 0. So if it's x to the first, it has 1 0. If it's x to the second, it would have 2 zeros, etc. When you use the fundamental theorem of algebra, notice right here, and the equivalence of zeros and factors, you obtain the linear factorization theorem. So in other words, if my 0 is 2, then my factor is x minus 2. And so for every 0, you have a factor that corresponds to that. And this is just a formal definition of those theorems. All right, let's move on. You can stop and write those down if you'd like, or study them a little bit further. We're going to do kind of go over them and use them by some examples that we're going to have. Rational zero test. This is really, really important, and I think that most of you might have done this last year in Algebra 2. The rational zero test, I'm reading right here, and we're just going to kind of read this together, and then we've got some examples to go over. The rational zero test relates the possible rational zeros, and that word possible is really an important word. The possible rational zeros of a polynomial having integer coefficients to the leading coefficient and to the constant term of the polynomial. So in other words, last year we probably referred to it mostly as what we call your P's and your Q's. Your P's and your Q's. So P and Q have no common factors other than 1, where P and Q have no other common factors than 1. P is a factor of the constant term. Okay, the constant term is that last term in your polynomial when it's in standard form. Q is the factor of the leading coefficient, which would be the first term, or the coefficient in front of your first term. And in this case, that's a sub n. So you have the factors of the P, which is, this is P, over the factors of Q, and that is Q. All right, let's keep reading a little bit. To use the rational zero test, okay, so we're reading right here. To use the rational zero test, you should first list all the rational numbers whose numerator are factors of the constant term and whose denominators are factors of the leading coefficient. So here it is right here, our possible rational zeros. And again, it's that word possible that's important, because it's only the possible one. It does not mean that they are all zeros, it's the ones that are possible. So in a little bit, when we're trying to find a zero, we're going to only pick numbers off the possible list, because any other number that's not on that list would not be a zero for sure. So it's basically a way to eliminate some possibilities. You take the factors of the constant term and you divide by the factors of the leading coefficient. Having formed this list of possible rational zeros, then we're going to use trial and error method to determine if there are any actual zeros of the polynomial. Note that when the leading coefficient is 1, the possible rational zeros are simply the factors of the constant term. Okay, this is really important. This is like the first step after we find our possible. So this is like finding the possible rational zeros is the first step, and then our trial and error method to find additional ones is our second step. And that's kind of the first two steps we're going to get through today while we're trying to graph and find some polynomials. And today I think all we're trying to find is the zeros. We're not even graphing until tomorrow. Alright, here's our first couple of examples. We're going to find the rational zeros of this particular polynomial right here. I'm going to change pen colors, so hold on one second. Okay, so because the leading coefficient is 1, notice it would be 1 right here. Because the leading coefficient is 1, the possible rational zeros are the factors of 6. So here's how you would do that. Normally, this would be our P, and then 1 would be our Q. And because of that, you would have positive and negative values of all the factors of 6 which would be 1, 2, 3, and 6. But they would be over all the factors of q, and this just happens to be 1. Since everything would be divided by 1, your possible rational zeros would be positive or negative 1, 2, 3, and 6. And those are all our possibilities. So to go on and find the zeros, these would be the values that we would utilize in synthetic division to see if we could find a zero. So let's go ahead and do that. Remember synthetic division. This will be a review of synthetic division. So I'm going to write that, review of division. And since we have this in standard form already and everything's in order, we'll take all the leading coefficient, or all the, not lead, but all the coefficients in front of the terms to set up our synthetic division. So we would have a 1, a negative 1, a 1, a negative 3, and of course last a negative 6. And we would do synthetic division. This is just a review for us. If I happen to do 0, 0 is not on my list, but I do want to point out something. This first set of terms, if the x values were 0, then my output would be negative 6. So on my graph, this is kind of important, I would have the ordered pair 0, negative 6, which would also be my y-intercept. And that's also going to help us graph. Just keep that in mind always when you list your synthetic division. All right, we're going to take list off our values from our possible list right here, and we're going to start synthetically dividing by those values to see if we can find a 0. So I guess we'll just start with positive 1. So if I use 1, I'm going to draw a little line here. I would bring down this 1. I would multiply 1 times 1. That's 1. 1 and negative 1 together would be 0. 1 times 0 is 0. 0 and 1 would be 1. 1 times 1 is 1. 1 and negative 3 is negative 3. Oops, no, sorry, negative 2. And 1 times negative 2 is negative 2, and that would be negative 8. So that did not find us a 0. But we do have another ordered pair, 1, negative 8. So an ordered pair at 1, negative 8. So let's try 2. Let's try 2. Now, you can rewrite every time, or I'm going to show you another little method. I'm going to erase this right here, so if you don't have it written down, you may want to pause first, and I'm going to set up my synthetic division just slightly different. So that means you're going to have to do a little more in your head. I may have done this on my past video, so take a look. I'm going to erase, I'm going to pause and erase it, so when it comes back, it's going to be erased, and I'm going to kind of start over so that I have more efficient use of my time. Or of my space, I should say. Okay, hold on. Alright, so I've erased. I'm going to set that up again. We're going to do 1 again just so you get this process. So when I start the next one, you'll know what I'm doing. So I'm going to go here. I am going to put in our coefficients again. So that was 1, negative 1, 1, negative 3, and negative 6. And I'm going to start synthetically by 1. And I'm going to just use one row so that I make a little better use of my space. So I would have to think in my head, bring down this 1. 1 times 1 is 1, and 1 plus negative 1 would be 0. 1 times 0 is 0, plus 1 would be 1. 1 times 1 is 1, plus negative 3 is negative 2. And 1 times negative 2 is negative 2, and negative 6 is 8. Okay, and so we got that one ordered pair. So next, I'm going to try 2, because 1 didn't work. I'm always going to go back right now and use these values. So I circle them, kind of help me keep that straight. I bring down this one right here to here. 1 times 2 is 2. 2 and negative 1 would be positive 1. 1 times 2 is 2. 2 and 1 would be 3. 2 times 3 is 6. 6 and negative 3 would be positive 3. And 2 times 3 is positive 6. Positive 6 and negative 6 would be 0. And I'm very excited, and I get a little party guy because I found a 0. So 2 is my 0. So I have an x-intercept, or a 0, at 2, 0. So on my graph, 2, 0 would be an ordered pair on the x-axis. Now, what I've done is I've gone from a 4th degree polynomial to a 3rd degree polynomial because I found a 0. My new polynomial has the coefficients of 1, 1, 3, and 3. So as I continue on to find more zeros synthetically, I'm now going to use this new set of numbers after I find a zero. But until I find a zero, I'd have to use the original set. Now I'll use this new set. So I'm going to draw my line, and I'm going to try another number. So we'll try 3. Remember, this is kind of the trial and error part. It could be -1 or 2 as well, but we'll go ahead and try 3, see how we come out. We're using the new set of numbers. So I take this one, bring it down. 1 times 3 is 3. 3 and 1 would be 4. 3 times 4 is 12. 12 and 3 would be 15. 3 times 15, that'd be 45. 45 and 3 would be 48. Okay, that looks like they're just getting really, really big numbers. So that ordered pair would be 3, 48. So there's another ordered pair, 3, 48, which would be an ordered pair on my graph. So now that that looks like it's getting really, really big, let's go and try a negative number. We're still going to use these values now here because we haven't found another zero yet. So let's try -1. Sorry, that got erased. All right. So we're going to bring down this one down here. 1 times -1 is -1. -1 and 1 would be 0. 1 times 0 is 0. 0 and 3 would be 3. -1 times 3 is -3 and 3. That would give me another 0. Woohoo! I'm going to get a party girl now. Okay, because we found 2. So they're having a little math party over here. So now I know I have a x-intercept at -1, 0. But more important, I now don't have a third-degree polynomial anymore. I now have a second-degree polynomial with the coefficients 1, 0, and 3. And I'm going to stop synthetically dividing and solve by quadratic. We know that we should have 4 possible zeros, and we found 2 of those. So I'm going to write those right here. I'm going to say x equals. Right now we have 2 and -1. Let's see what else we can find with our quadratic. So now we have 1x squared, or x squared. We have 0x, so I don't need that. We have +3, plus 3. And we'll set that equal to 0 to find. We'll move the 3 over. We get x squared equals -3. Looks like we're going to have an imaginary number. We've learned those the last few days, our complex numbers. I take a square root. I take a square root. I get x equals. It'll be positive or negative. I'm going to take an I out. Remember, real monsters. I'm going to take an I out for the negative, and I'm going to have the square root of 3i. And that's positive and negative, so that's 2 roots. So my rational roots are now 2, -1, and then positive and negative square root of 3i. All right, and those are my 4 roots. All right, let's try one more example. Again, P's and Q's. We're going to find, you're using this polynomial right here. Our factors of 3 were 1 and 3. Our factors of 2 are 1 and 2. And all our combinations, we would have 1 over 1, which would be 1. We'd have 1 over 2, which is 1/2. We'd have 3 over 1, which is 3, and 3 over 2, which is 3/2. And of course, it would be the positive and negative value of each of those. For me, you can just write the plus or minus sign 1. So I would have positive or negative 1, 3, 1/2, and 3/2. All right, so now let's see what we can do. Again, using synthetic division, trial and error. Oh, by the way, take a look. Go back for just a second. Take a look right here about this study tip I wrote down for you. When the list of possible rational zeros is small, it may be quicker to test the zeros by evaluating the function. That would mean by taking these numbers and actually plugging in for the x to see if they equal 0. But when the list is large, it may be quicker to use a different approach to test the zeros, such as using synthetic division or sketching a graph. And that's what we're doing right now is synthetic division. So that's just a little tip for you. All right, back to our problem. So these are our possible rational zeros. Again, what that means is, that means when we start synthetically dividing, if there is a rational zero, it's going to be one of these numbers. Okay, it would never be 5 or 10 or something that's not on the list. This would be the only list of numbers that it could possibly be. All right, so let's get up our synthetic division like we did a while ago. Our coefficients are 2, 3, -8, and 3. And we had a degree of 3, so we know we should have 3 zeros. So we're looking for 3 zeros. So our x values are going to be something. So this is kind of our answer area up here. All right, so we're going to start. We know that that's 0. 0, 3 would be an ordered pair, not a 0 because it's not a remainder of 0, but an ordered pair would be 0, 3. It's important to recognize the ordered pairs because it's going to help give us a better graph when we have more points on our graph. All right, so let's go ahead and just start with 1 and see if 1 works. We would bring down this 2. 1 times 2 is 2. 2 plus 3 would give us 5. 1 times 5 is 5. 5 and negative 8 would give me a negative 3. Looking pretty happy right now. 1 times negative 3 is negative 3. And negative 3 and positive 3 would give me a 0. Woohoo! I'm my first 0. And I'm extremely happy because now I went from a third degree polynomial when I used these coefficients. Now I've knocked out a degree. I'm down to a second degree polynomial, which means I'm at a quadratic. So let's take a look at that. So that would make me have 2x squared plus 5x minus 3. All right, we have two options now. We're going to solve this using not synthetic division anymore. We're going to either, since we have a coefficient, we can try our slip and slide method. If slip and slide works, perfect. If it doesn't work, then we're going to scrap that process and we're going to go straight to the quadratic formula. Let's see if by chance we can factor this or not. I really don't know. We'll take a look. So I would slip the 2 over here and I would end up with x squared plus 5x. 2 times negative 3 is negative 6. So I need to multiply to negative 6 and add to positive 5. I actually think I can factor. So I would have x and x. Negative 6 add to positive 5. So I think I get a positive 6 and a negative 1. That would get me my positive 5 and my negative 6. Then don't forget, you've slipped the 2 over. Now you need to slide it back into your problem. So go under the 6 and under the 1. So now you have x plus 3 and you have x minus 1/2, which gives you my two other zeros. The first 0 we found was 1, so 1 was our 0. Now we have x plus 3 equals 0, so that means negative 3 would be a 0. And we have x minus 1/2 equals 0, so that means 1/2 would be a 0. So those are my 3 zeros, and that gives me a big O happy Bearcat face. All right. The last thing I want to do is I'm going to work 2 problems from your classwork for tomorrow. So you'll have 2 more examples. After I work those, then I need you to make sure you have these written down for tomorrow. And the second example I work, I want you to bring it in on a piece of paper, and I want you to turn it in for me tomorrow. So the second problem I work tonight, which is the last problem of the night, I want you to bring it in on a piece of paper. All right. First example. Number 11. Actually, why don't you write both of these down? Because this will just get your classwork started. So what I will do tomorrow, change my mind. What I'm going to do tomorrow is you're going to come in and I want you to have it out on your desk in your spiral, ready to go. And these 2 problems will already be done. Go ahead and mark them. Page 179, classwork, 2.5, day 1. So that'll just get you started on your classwork, and I'm going to come by and give you a check mark in my book right off the bat, and you get 100 for doing this and listening to the video tonight. And then you should be able to zip through the other few problems you're going to have. I think you'll have, like, I don't know, 5 more to do tomorrow in class for practice. All right, so number 11 would be your first one here, and you'll go back and you can work. Actually, that's the very first one you're supposed to work anyway. All right, so the problem is f of x equals x cubed minus 6x squared plus 11x minus 6. All right, P's and Q's first. All right, P's over Q. Ooh, I didn't do that very good. P's over Q first. So it's going to be plus or minus. Since it's 1, everything's going to get divided by 1. It's just the factors of 6, which would be 1, 2, 3, and 6. So these are our possible roots. Let's set up our synthetic division. 1, negative 6, 11, negative 6. And we'll set up our possible rational roots. So we know that that would be 0. So we know, I'm just going to write the word points over here. These are points on our graph. 0, negative 6. That's actually a y-intercept as well. All right, so the next thing I'm going to do is I'm just going to try the first one on the list, which is 1. I'm going to circle these because these are the values I have to use right now. So I bring down the 1. 1 times 1 is 1. 1 and negative 6 would give me negative 5. 1 times negative 5 is negative 5. Negative 5 and 11 would give me positive 6. Ooh, looking good. 1 times 6 is 6. 6 and negative 6 would give me a 0. My first x-intercept party guy. All right, so x is equal to 1 is one of our zeros. We need 3 zeros because we have a third degree polynomial. But remember, we went from a third degree polynomial, now we're down to a quadratic. Once we're at a quadratic, I'm going to solve by the two quadratic methods, either factoring or not completing the square, quadratic formula. So my coefficients now would be 1x squared, or just x squared, minus 5x plus 6. Looks like I could factor this one, x and x. Multiply to positive 6, add to negative 5. 2 and 3 might work. Negative 2, negative 3. Negative 2 times negative 3 gives me positive 6. Negative 2 plus negative 3 gives me negative 5. Think that's good? Equal to 0. So my zeros would be 2 and 3. So up here, my answers are 2 and 3. And those are my zeros of that function. All right, one more. And like I said, you should have this written down at the beginning of class. I'm going to check right when you come in tomorrow. And you'll be ready to go. And you can just keep working. So come in and just get working. You'll do number 13 when you get to class tomorrow. All right. I'm going to work number 19. All right. Kind of a big polynomial. Fourth degree polynomial. It's a fourth degree polynomial with big numbers. So all our P's and Q's are going to be pretty big list here. So positive and negative. And we're going to have factors of 24. And there's a lot of them. There's 1, 2. I don't know what I did there. Hold on. One, 2, 3, 4, 6, 8, 12, and 24, and they'd be over the positive and negative factors of 9, which would be 1, 3, and 9. So quite a list we have here. So let's take a look at that, and that would be, of course, everything over 1 would give me just 1, 2, 3, 4, 6, 8, 12, and 24. But then we would also have everything over 3. So 1/3, 2/3, 3/3 is 1, 4/3, 6/3 is 2, 8/3, 12/3 is 4, and 24/3 is 8. So we've already gotten those. Then we have to put everything over 9. So 1/9, 2/9, 3/9 is 1/3. We already wrote that one. 4/9, 6/9 reduces to 2/3. 8/9, 12/9 reduces to 4/3, and 24/9 to 8/3. So we're good there. All right, so that would be our list of possible rational roots. Wow, that's a big list. That could be a long evening. Let's see what we can do synthetically. Tomorrow I'm going to talk to you about another way to narrow down your list when you have such a large list. I have a little hint for us so to make the evening go a little bit quicker. To make the evening go just a little bit quicker. So let's go ahead and set up our synthetic division. We need to find two zeros through synthetic division before we can get to a quadratic and find the last two by the quadratic methods. All right, so let's go 9. Oops. So we'll have 9, negative 9, negative 58, 4, and 24. And we have all the degrees, 4, 3, 2, 1, and of course 0. So we know that that ordered pair is 0, 24. So our points we're finding are 0, 24. Sometimes it's helpful to sketch, and we'll talk a little bit more about that tomorrow. Let's just start with negative numbers. I don't know why I want to start with negatives, but we're going to start with negative this time. We'll start with negative 1. We bring down the 9. Negative 1 times 9, negative 9. Negative 9 and negative 9 would be negative 18. That becomes a positive 18. Positive 18 and negative 58 would be, looks like 40. So that would be positive 40. Negative 1 and 40 would be negative 40. Negative 40 and 4 would be negative 36. And negative 36 and negative 36 is positive 36 and 24. We're back up. I think that puts us at 60. All right, well, that didn't help, but there's another point. We have a point at negative 1, 60. Wow, that looks like really big. All right, so let's try negative 2. Now, remember, we're using these values because we haven't found a 0 yet. Bring down the 9. Negative 2 times 9 is negative 18. Negative 18 and negative 9 would be negative 27. Negative 2 times negative 27 is positive 54. Positive 54 and negative 58 is a negative 4. All right, negative 2 and negative 4 multiplied is positive 8. Positive 8 and 4 would be positive 12. And negative 2 times 12 would be negative 24. And positive 24, that gives us a 0. Woohoo. There we go. Go Bearcats. All right, so we found a 0. So our zeros are x equals, we found 1 at negative 2. All right, just because I have a little helpful hint, I'm going to go on and kind of shortcut us. Tomorrow we'll talk about that you do sometimes need to go on trial and error, and I'll give you a couple other ways to narrow things down. We are now at a third degree polynomial with coefficients 9, negative 27, negative 4, and 12. Just to save us a little time on the video, I'm going to say that we tried positive 1 and it didn't work. We tried positive 2 and it didn't work. And now we're trying positive 3. I'm not going to go through all that division tonight. So we would bring down the 9. 3 times 9 is 27 and negative 27 would be 0. 3 times 0 is 0. 0 and negative 4 is negative 4. 3 times negative 4 is negative 12 and 12 is a 0. All right, party girl, we're happy. And we have confetti at some point. Not yet, though. We have to work a little more to have confetti. All right, so our next 0 we found at 3. Excuse me, positive 3. We now have coefficients to a quadratic. So we would have 9x squared. We'd have 0x minus 4 equals 0. And we can just solve this. This is kind of extracting a square root. We'd move the 4 over. We'd have 9x squared equals positive 4. We would divide by 9. We have x squared equals 4 over 9. And we would take the square root. Take the square to the top and the bottom. We are an artist. So we would have x equals positive or negative. The square root of 4 is 2, and the square root of 9 is 3. That equals really, really nice. That's two solutions, positive 2/3 and negative 2/3. So our x is also positive or negative 2/3. And that would be our 4 zeros. All right. Well, that was one of the harder ones. So when you come in tomorrow, you're going to bring these two problems to start with. You're going to start on problem 13. You'll work 13, 15, 17. And then I think you'll work 21 and maybe 23, and you'll be done. So I think that gives you 5 problems to work in class tomorrow, and you should be well on your way. Hope you have a really great night, and go Bearcats!